Welcome to The Explainer. Today, we're driving into the world of graph databases, and specifically, one of the biggest names out there, Neo4j.
You know, when you really stop and think about it, our world is just fundamentally built on connections, right? People are connected to other people, the products we buy are connected to our purchase history, every single financial transaction is connected to an account. It's all this massive, intricate web of relationships.
And that's the real challenge, isn't it? I mean, it's one thing for us to intuitively get these connections, but it's a whole other thing to make our data actually understand and navigate this web efficiently. So how do we pull that off?
Well, to really get why a solution like Neo4j is so powerful, we first have to talk about the problem. And that problem? It's all about how we've been storing our data for the last few decades. For years, the undisputed king of the data world has been the relational database. It organizes everything neatly into tables, with rows and columns. Just think of a giant, superstructured spreadsheet. It's rigid, it's strict. But graph databases like Neo4j, they think completely differently. They store data as a flexible graph of what we call nodes and their direct relationships. So what's actually wrong with tables? Well, the second you need to find out how different pieces of data connect, a relational database has to perform these complicated operations called joins. It has to look up data on one table, then jump to another, then another, trying to piece all the clues together as it goes. And as your data gets bigger, that process gets slower and slower and slower.
And this, right here, is exactly where graph databases just shine. They use a brilliantly simple and intuitive model that's literally designed to mirror how the real world is actually connected.
Okay, so the first building block is the node. A node is really just a thing, an entity. It could be a person, a company, a product, anything you want to track. So for our example, let's take an NBA player, LeBron James. He's a node. Simple as that. Now this is where the magic really happens, with relationships. These are the direct connections between nodes that tell us how they're related. A relationship has a direction and it has a type. So our LeBron James node has a plays for relationship that points directly to the Los Angeles Lakers node. It's clear, it's direct, it's just there. And really, when you boil it all down, this whole incredibly powerful system is built from just 4 core components. You've got your nodes, the things. You've got your relationships, the connections between them. Then you have properties, which is just data you can stick on either a node or a relationship, like a name or a salary. And finally, you use labels to group similar nodes together, like labeling certain nodes as a player or a team. This brings us to a really important idea, the native graph database. This is kind of the secret sauce. In Neo4j, these relationships, they aren't just some abstract concept the database figures out when you ask a question. No, each node physically contains pointers. Think of them like little signposts that point directly to every other node it's connected to. The connections are stored, not computed on the fly. And because those relationships are already built right in, asking the database about connections is unbelievably fast. You see, it doesn't need to look up anything in a big index. It just follows the pointers from one node to the next. For complex queries with lots of connections, this can be literally orders of magnitude faster. Okay, so it's fast and it's intuitive. But why does this structure actually matter? Well, let's take a look at how this model is being used to solve some incredibly complex, real-world problems. A huge one is real-time fraud detection. See, fraudsters almost never work alone. They operate in these sophisticated, hidden networks. A single transaction might look totally innocent by itself, but the network it's a part of can tell a very, very different story. And this is where the power of the graph model just clicks into place. By mapping every single person, account, and device as a node, a graph database can instantly spot these suspicious patterns in the connections. It can see when multiple accounts are all sharing the same device or address, and suddenly, bam, you've uncovered an entire fraud ring in real time that would have been almost invisible otherwise. This exact same power is also completely changing the recommendation engines we use every day, from what to buy online to what movie you should watch next. So instead of just looking at your past purchases, a graph engine understands the whole web of connections. It connects what you've viewed to what your friends have bought, to what other people with similar tastes enjoy. And because of that, it can make these incredibly accurate, context-aware recommendations that feel genuinely helpful, not just random. But honestly, fraud detection and recommendations, that is just scratching the surface. The potential for thinking about data in terms of its connections is absolutely vast.
I mean, we are seeing this technology pop up everywhere, from optimizing these insanely complex global supply chains to analyzing social networks to integrating all this different health data to get better patient outcomes. Heck, graphs are even becoming a cornerstone for more powerful and more explainable AI.
So, what's really clear here is that this isn't just about a new type of database. It is a fundamental shift in how we see and interact with our data. It's about finally prioritizing the relationships that give our data meaning. And that kind of leaves us with one last thought to chew on. As our world and our data become even more interconnected, what incredible new insights and patterns are we going to uncover next?